Now, in order for you to be truly good at being able to optimize, maximize, and minimize a variety of problems, you need to be good at drawing diagrams. And that's what we're about to do now. And that's the first step of this next example. So let me read it to you. The problem states that we have a piece of wire and it's 24 centimeters long and it is bent into the shape of a rectangle. And what we're asked to do is find the maximum area inside that rectangle from that 24 centimeter piece of wire. So we're going to take it in 3 steps. Step number 1, we're going to draw a detailed diagram. Then step number 2, we're going to write up some formulas and construct them in such a way where the variable to be optimized is the subject. And finally, we're going to start differentiating first and the second derivative in order to find whether it's a maximum or a minimum area. So the first thing we want to do is construct that diagram. So what do we got? We got a length of wire, 24 centimeters, bent into the shape of a rectangle, and we have to maximize the area in that. So a quick diagram, we just draw a rectangle. So it would look something like this. There's just a rectangle, and with that rectangle, what we have is a length across here and a length across there, and we need to find the maximum area, and that's the red area in there. That's what we're after. So what do they give us? Well, the length, as I said, is 24 centimeters, which is the perimeter. So they give us the perimeter, and then they ask us to find the area. They don't give us the area. They don't give us the length of the length or width of that area, but they give us the perimeter. So how do we work this out? Well, let's write up what we have first of all. Well, first of all, what we have is the perimeter, don't we? So the perimeter is the length of the wire, and that equals, well, what do we have? We have an X here and an X there, a Y there and a Y there. So we've got 2 groups of each. So we've got 2X plus 2Y. Now the length of that wire is 24 centimeters. What else do we have? Well, that's it. They want us to find the area from that. Do they give us the area? So what is the area? The area equals X times Y. So we need to maximize it. They give us the perimeter, they want us to do the area. And they give us nothing on the area. So how do we do this? Well, what we want to do is we want to maximize or optimize this A here, because that's what we're going to differentiate in a moment. But we can't do that because we have an X and a Y. We can't differentiate with respect to X or with respect to Y because we've got 2 variables. So we have to transform this equation to be optimized where we have 1 variable. And the good news is they give us these 2 formulas to turn it into 1 variable. So I'm going to show you how to do that. So we can put this in terms of 1 variable, meaning X. So how do we do that? Well, what we're going to do is we're going to take this perimeter and make Y the subject. So how do we do that? Well, let me just write it up here again. We know that 2X plus 2Y equals 24. And if we halve it throughout, divided by 2, we'll get X plus Y equals 12. That's still a valid equation. And what I'm going to do is I'm going to make Y the subject so we can have X. We're going to take Y over to this side, sorry. So we make X the subject. And if X is the subject, we can substitute it in here. And if Y is the subject, we can substitute in there. We just take our pick. How about we make Y the subject? Yeah, we'll do that. So Y equals 12 minus X, doesn't it? I just made Y the subject, threw X over that side. There's our new equation. So if Y equals 12 minus X, isn't it true that we can take that and replace the Y here? And that means everything will be in terms of X. So let's do that. So now area equals X times, drag and drop this over here and replace the Y, we'll have 12 minus X. There we go. There's no Y's there, just X's. So now it's easy to differentiate, isn't it? Because it's in terms of X. So we do dy dx. So let's expand this and write it up as follows. So A also equals 12x minus x squared. Now it's a lot easier to differentiate it. So let's do that. Let's differentiate it. And why would we want to differentiate it? Because we want to get the maximum area. And because we want maximum area, that has to be the subject of the formula. All right, so let's do that now. So let's find what A dash is. So I'm going to write it down over here. So just bringing it up here. So A prime equals 12 minus 2x. Here we go. First derivative. We have it. Now, what do we need to make it in terms of maximizing and minimizing? We need to make it equal to 0. So make it equal 0. So that means 12 equals 2x. If we bring the 2x over, because it's negative, so we add 2x to both sides. Make x the subject, divide both sides by 2. Therefore, x equals 6. Well, there you go. X equals 6. So if x equals 6, isn't it true we're going to find what y is? Let's find the corresponding y. Well, all you have to do is substitute back up into this right over here, and we can find what y is. So let's do that now. So y equals 12 minus x, which is 6. Therefore, y equals 6. So y is also 6 if we want to maximize the area. So how do we know that it's a maximum or a minimum? I mean, all we did was make it equal 0. It's a stationary point. Could be a max, could be a min. Just in case, let's actually do this. Let's find the second derivative and confirm that it's optimized as a maximum. So the way to do that is differentiate the a again. So if I was to do the a again, I would go a prime prime, double dash, second derivative is negative 2. There it is, negative 2. Now what's that? That's a less than 0, obviously. What does that mean? It means it's going to be a great, we got a maximum. That's awesome. So now that we got a maximum, we know that when x equals 6 and y equals 6, we're going to have the maximum area. So the maximum area is going to be, all we have to do is slot it back in here. Maximum area is equal to x times y, which is 6 times 6. And it's all in centimeters. So the area equals 24 centimeters. Actually, no, it's 36. What am I doing? 6 times 6 is 36. 36 centimeters squared.